Hi class and welcome back. This week we get into a little bit more object-oriented programming in Java, and it typically introduces a lot of new terminology and a lot of new syntax. So I wanted to make sure to walk through an example or two with you to help you with these concepts. If you haven't had much of an introduction to object-oriented programming, um, students have shared with me that this is probably one of the more difficult weeks. So, stay with it. Don't give up. Trying these examples is very helpful. And definitely make sure to read the textbook because it does a good job of explaining object-oriented programming. With object-oriented programming, the basic idea is to model programming after real-life objects. So if you think about how we interact with objects every day in our lives, um, we interact with it, for example, in a registration system for a school, we would interact with student objects. And a student has a last name, a first name, an S number, and all of these different properties. And even though they're individual pieces of data, they all belong collectively to a single student. So when you have a lot of data that's related in that way, it's not advantageous to have a bunch of separate variables in your main program. I mean, you could have a SSN and an L name and an F name and all of that, but then you start getting into troubles when you have multiple students, and then you end up creating arrays of this data. And although it's possible to store multiple students' information in this way, it's not as natural as object-oriented programming. Object-oriented programming also promotes code reuse and abstraction. So once you build a class, which is something we'll see momentarily, you're able to reuse it many times. So it's very powerful. And as you get into further concepts with object-oriented programming, you also find out that there's a concept called inheritance that allows you to build a hierarchy of related data types, related classes. So it just builds on that efficiency by creating hierarchies of classes. But that's a little later. It's very useful for code reuse and abstraction. Abstraction because it allows you to abstract away details and interact with objects in your code, like student object, for example. So let's look at some examples because a lot of this is very abstract and it's kind of hard to understand without seeing it. The first thing I'm going to do is I created 3 projects over here on the left. They're really the same project, just 3 different versions of it, starting with the most simple one, GB. I created that called Gradebook. Largely the project name's pretty much irrelevant. Inside though, I created a class called Gradebook. And Gradebook is a very, very simple class. First of all, you can see where it says public class, Gradebook, open curly brace, close curly brace. The thing that might be a little unusual is that you'll notice it doesn't have a main method. So unlike the other classes that we've created in the past, this isn't an application. You can't run it if you hit execute and you had only had Gradebook in this project, it would not run. There's nothing to run. It's not an application. Instead, this type of class, this user-defined class that we're creating, um, is really representative of a blueprint of what every object of type gradebook is. So we've worked with types before. You guys have created programs that used int type for integer, double for floating point, and so forth. We're creating our own type called gradebook. So instead of one of the primitive built-in types, you're actually creating your own type. And it's a complex type that has, multiple attributes. Now at this point, the class we're looking at, very, very simple. It doesn't actually have any data in it. We'll see an example in a minute that does have a variable storing data. But for right now, if you look at it, it really just has a single method called display message. And display message just says welcome to the gradebook. So this is a method, remember that's just a named block of code that does some sort of task. just a little bit of information about syntax. Public is an access modifier. That means that any other class will be able to execute this method from the gradebook class. Void means this method doesn't return anything. It certainly outputs something, but it doesn't return anything back to the block of code that called it. There is no return statement. So we say that it's void. Display message is the name of the method, and then the empty parentheses indicate that it is a method that does not receive any information. There's no parameters in between the parentheses. And then finally, we've got the open close curly brace. So very, very simple class. As I said, a class is like a blueprint. So we can create this gradebook class, and from it later create mini gradebook objects. So it's kind of like a recipe. If you think of a recipe for a cake, it has all the information about what a cake is or what it can do. In this case, it's just what it can do. It can display a message. Our gradebook class can display a message, but it doesn't, a recipe is not actually the cake itself. So this describes what a gradebook is, but we have to create another class. We've called it gradebook test over here, so that we can actually test out this class and use it. And this is going to have more of the familiar underpinnings that we're used to. We have a main method. This is what's executed when we execute our project. By the way, the book calls this a driver class. It's really nothing more than just an application that tests out our gradebook class. That's all. So we have a lot of the same familiar things, but let's take a look. Inside of main, what we really wanted to do was to create a gradebook object. So the way that we do it is on this line right here. Now the first part of that looks like a variable declaration. Instead of an int or a double or a boolean or a string, we're creating a object of type gradebook. My gradebook is the identifier, in other words, what the name we give it, it could be anything, equals new, indicating to create a new gradebook. So this name over here is going to match up to the data type on the left-hand side of the equal sign. This piece right here is actually a call to the constructor, which the default constructor for the class, which says when you're creating this object, set all the variables inside of that class to their default values. And we don't have any variables at this point, but just understand that this is calling something called a constructor, and we'll see more of that later. So line 9 creates a gradebook object. Now, here's the fun part. Once that object is created, we can access from this class, gradebook test, any of the public methods or variables that are declared in the gradebook class. So if you flip back over, super simple. I only have one method, and it's public, which means that gradebook test can see it. And here we call display message. But notice if we just call display message, it's going to say, I don't know what that is. There is no display message in gradebook test. So the way that we are able to access members, we call it, members are methods and attributes in another class like gradebook, the way we're able to access them is by using the name of the object, which we gave it the name my gradebook, and then this is actually an operator. The dot is an operator, and it precedes whatever it is we're trying to get from that object. So we're trying to execute display message, so that's what we put after the dot. Note that when it hits this line of code, it's actually going to jump over here and execute all of the code inside of display message before returning control back. So if we run this, it's so very, very simple, but it does illustrate how to create an object. So we see the welcome to a gradebook, the effect of calling display message on the my gradebook object. Now, truthfully, you rarely have a class with just one method in it, and in general, classes usually have data that you're storing. So let's take a look at another example. I called this one GB2, and it's very similar, but we have this class called Gradebook. Remember, the former version had this display message method. We're pretty much doing the same thing, but now we're going to say welcome to the gradebook for blank, where blank is the course name. So we need to be able to store a course name so that, for example, if this is the gradebook for Java, we're able to store that information. And we know that in a program, the way that you do that is that you use a variable. So classes can have variables defined inside of them. We call them instance variables or attributes. And what this means, this line 3 up here, is that every object of type gradebook that's going to be created will have this attribute. It will have a course name of type string. We generally make our instance variables private, meaning that only methods defined within the gradebook class can access this variable directly. We do that so that we have tighter control over that data, so that, for example, if course names can only be 10 characters long, we can write a little bit of code to ensure that they're only 10 characters long. Or whatever kind of business rules we have, we can implement them in the gradebook class. So we generally make our variables private, but we're going to see in a moment that gradebook test might need to have access to that course name to set it or to read it. So we turn around and we create two public methods. Here they are, set course name and get course name. And this is a common pattern you're going to see in a lot of the object-oriented solutions, where there is a public set and then the name of the variable set course name, and it's used to update that variable's value. And then we have a get, which returns that variable's value. So let's take a look at set course name. Set course name receives input. We're calling this parameter name. This is largely irrelevant what this actual identifier is. You could call it anything. You could even call it, and the book does this, the same identifier, course name, as used in the class. Now, the only problem with doing that, that's actually a technique that programmers often use, is that down here on line 8, where we say set this variable, we're referring to this guy up here, equal to what we just passed in, we're not able to differentiate between them. So the this, keyword this in Java, dot, if you put this before the name of the variable, it will refer to this object's attribute. So in other words, this dot course name refers to this variable here, and it says set it equal to what I just passed in. So if I passed in Java for the course name, it sets it to Java. So set course name can then be called from gradebook test, because this is a public method it's going to have access to. It's also going to have access to get course name, which doesn't receive any data, but it returns a string. The return type is string, and you can see the return statement here is returning the course name. You could add this dot course name to be extra clear, to say I'm using this course name up here. It's actually not required in this case because I didn't have a conflict of names in the scope of this method. I didn't actually pass anything in. But you can add that if you want to. And finally, display message just displays welcome to the gradebook 4, but in place of this format specifier for a string, we got the course name. We actually called our own method, get course name, which we know will return the course name. So again, this is a class that you can utilize in an application. It doesn't have a main method. I can't execute it directly, but now I have a blueprint from which I can create gradebook objects that each have their own course name. So let's see how that's utilized in gradebook test. Gradebook test threw in a little bit more here and said, well, let's get the name of the gradebook from the user. So you guys know we need a scanner object to do that. So we import scanner. We create a scanner object so that we can read from the user. And this line here, line 12, actually creates a gradebook object, just like we did last time. And we did it here. We could have done it actually before this statement as well. But we created this because we anticipate interacting with it very soon. So, but first, we get a course name. So we ask the user, enter a course name, and we read it in. Next line, it works like next int that we saw in the previous chapters, but next line is for strings, and we'll read whatever is typed on the whole line of text from the user, reads it in and assigns it to a string called the name. And then here we're using mygradebook.setCourseName to pass whatever that name the user just gave us in as the value. So in other words, if the user typed C++ in at the command prompt, then C++ is read in for the name, and C++ is what's passed to set course name. This is just going to add a blank line so it looks a little nicer, and then finally, just like before, we call display message method from this object, myGradebook. This time though, it should reflect the course name that we entered as the user. So if I am the user and I type in Java programming, it says welcome to the gradebook for Java programming. So we see that input working. Some of the common questions I get from students is, this local, we call this a local variable, in main is called the name. We're passing it to set course name, but if you look at set course name, its parameter is called course name, not the name. Does that matter? No, it doesn't matter. Those can be named anything that you want, because this is in the scope of this method, and this one is in the scope of this method. But the mapping will work out just fine because it works positionally. Whatever the first argument passed in between the parentheses here is will be matched to the first argument in this parameter list. We only have one parameter, so it's kind of a moot point. The one will be passed in for the other, but the names do not need to match. They can, but they don't need to. So that actually takes you pretty far here, understanding a little bit more about variables and how we can access them with the gets and sets. One more concept that's really important to object-oriented programming is this. If you look up here, we created a gradebook, and then later we got the course name and we set the course name. But what if we knew the course name ahead of time? What if we wanted to, when we created the object, to initialize the course name to a specific value? And that's what this third example shows. So let me actually close these to avoid confusion, and let's look let's start with gradebook test this time. Now this time we got away from asking the user for the course name, but we certainly could put it back in. We'd have an import up here. You could try this out yourself, create a scanner object here. Same thing we did last time, prompt and read into the name and so forth, and then just pass in the name here. But for simplicity's sake, we actually just hard-coded this value. Actually, our new name for the course is CSE 231 to avoid confusion. But we're creating a gradebook object here, and we're passing in the name of the course right away. And that's really convenient when you know the value that you want to use to initialize your variable ahead of time. And by the way, if there had been more than one variable in that class, we would have just used a comma after this one and added what the second value would be and the third value and so forth. Our particular class only has one variable, course name, so we only pass in one value. But let's see what happens if we create a new gradebook and we pass in this value, and then we reference the object name dot display message, we should get our welcome to CSE 231 Java programming. And there you have it. You could go ahead and try it out by reading in the user's input and passing it in. That'd be a good exercise to try. But in order for this to work, if you had only made this change, you would get errors that say that there's not a constructor that accepts this number of parameters or something similar. So we had to make an adjustment to gradebook. So first, let's look at all the common things that we're used to seeing. In the previous iteration, we saw set course name, we saw get course name, we saw display message. All of that is exactly the same. So is this up here. We still have a course name. So the new piece is right here, lines 7 through 11. We added what's called a constructor. So every class has a constructor by default. It's called the default constructor, and it initializes the value of every variable, that's these guys up here, to their default value. So for example, for a string, the default value is null. So if we didn't have this constructor, it would set the course name to null when we first create a gradebook object. But we didn't want to do that. We wanted to pass in a value of welcome to Java programming. So in order to do that, we have to create a special method called a constructor. And a constructor has very specific syntax. It needs to be public. There's no return type. If you compare it to these other methods here that all have return types, that indicates what it returns, there is not a return type. Also, the name of the constructor must match up to the name of the class. So it always is going to say gradebook. In between parentheses is what we're passing in. That's the parameter. And just like last time, if you wanted to call this course name, you could. Just make sure to write this dot course name here on the left-hand side for the same reason I explained earlier. But this is going to pass in a name, and that name is going to be used to update the variable, the instance variable called course name. So if I wanted to, I could create multiple gradebook objects. So I could, if you're actually taking C++ right now, you'll see a lot of similarities between the two programming languages. In fact, Java was based on the C language. So there's a lot of similarities. But I did a copy paste, which led me to this error. You can't have a variable or an object name with the same name as another, just like any time you create a variable. So I'm being super generic here, but I'm going to write in my gradebook 2, and then I'm going to display the message for that object. I could have interleaved these in a different way, created both objects, displayed both messages at the same time, just chose to do it this way. Got my output up there this time. But you can see our two outputs here for Java and C++ are working out. Now, in general, for those of you that have had data modeling or the structured query language class, you know that data is usually stored in tables in a database, and there's a lot of them. There's a lot of rows in data that is used in practice, and you might not have, you know, a single line of code for every row that you're reading in from the database. But there's a lot of classes built into Java that make that process easier. So I could, for example, read a whole table from a database and, within a short amount of code, actually create a, whole collection of gradebook objects. So that's the power of being able to create objects. Here I'm creating two manually, but there is a lot more that you can do with it. Or you could create a loop to create objects. So that just gives you some examples. One more thing I wanted to add on here is if you have more than one instance variable, You can add it here up at the top. Can you add instance variables here or here or here at the end? Yes. In Java, it doesn't matter. They can actually be anywhere, but it's conventional to use camel case and to put them at the top of the class so that they're easy to find. So hopefully that gave you a good introduction. Definitely make sure to read the chapter this week. If you have questions, reach out. The best way to learn this, if it's new to you, is to practice and try out some of these examples.